Hey everyone, and welcome. So, if you've ever built a single page web app, you definitely know that feeling, that dread when an unstable network connection rears its ugly head. Today, we're going to dive into how the wffweb framework has this really elegant built in solution for one of the biggest headaches developers face, keeping your UI totally consistent, even when the network starts acting up. I mean, seriously, just think about it for a second. Your user's in the middle of something important. They're clicking around, data is zipping back and forth, and then poof, the connection drops. Maybe for a second, maybe for longer. What actually happens to your app's state in that critical moment? Well, what happens next is pretty much chaos. The UI that your user is looking at, it no longer matches what's on the server. So any actions they take after that start failing in these bizarre, unpredictable ways. Data can get corrupted, and, worst of all, your user is just left staring at a broken page, getting more and more frustrated by the second. And that, right there, is the heart of the problem we're tackling today. It's this idea of the unreliable connection. Look, trying to keep a perfect one-to-one state between a client and a server over a network that is just fundamentally unreliable, that's easily one of the biggest challenges in all of modern web development. And this is exactly where wffweb comes into the picture. See, it's a Java framework that was specifically built for the kind of apps where failure just isn't an option. We're talking about really high-stakes stuff, like banking platforms, financial trading systems, real-time analytics dashboards, places where data integrity is absolutely everything. So you have to wonder, how does a framework built for these kinds of environments handle something like a network failure? Well, it doesn't just leave it up to you to figure it all out. Nope. It comes with this built-in, totally automatic safety net that's designed to protect your app's integrity right out of the box. And that safety net has a name: Lossless Browser Page Communication. And you want to know the best part? It's been enabled by default ever since version 12 of the framework. That right there tells you just how critical this feature is to the whole wffweb philosophy. This isn't some optional add-on. It is the standard. Okay, so how does this thing actually work? To really see its power, we gotta pop the hood and look at what's happening during a payload loss. So let's start with a super common scenario. The client misses a critical update from the server. All right, picture this sequence of events. First, the server tells the browser, hey, add this div. Done. Works perfectly. Next, it sends another command to add a second div, but that packet gets lost somewhere in the ether. The network glitches. Then the connection comes back, and the client gets a third command which says, replace that second div you just got. Now, what's supposed to happen here? A normal app would probably just crash or throw an error, but wffweb is smarter. It's been keeping track. It knows that the second div never showed up, so it immediately realizes that command number 3 is now invalid. And what does it do? It just ignores it. It prevents the UI from entering a corrupted state. It's that simple. So, after it intelligently ignores that invalid command, what's next? Well, by default, wffweb immediately runs a predefined JavaScript action, and that action is to simply reload the page. It's a clean, safe fallback that just guarantees your user is always looking at a perfectly consistent and up-to-date UI. No weirdness, no corrupted data. Now, here's what makes this feature so incredibly robust. This is not a one-way street. The protection is completely bidirectional. The framework is just as watchful for messages going from the client to the server. Okay, let's look at the side of the coin. A user clicks button 1, server gets it, awesome. Then they click button 2, but that network gremlin strikes again and the event packet is lost. Finally, they click button 3 and that one makes it to the server. Just like on the client, the server is keeping score. It sees this event from button 3 show up, but it knows it's expecting an event from button 2 that never came. So to stop itself from processing events out of order and messing up the state, it simply ignores the event from button 3. And the recovery here? Well, it mirrors the client side perfectly. The server runs its own default action, which, you guessed it, tells the browser to reload the page. This symmetrical approach, it ensures a consistent, predictable, and super safe user experience, no matter which direction the packet loss happens. Now, you might be thinking, okay, this sounds great, but is it just some magic black box I can't touch? And the answer is no. What's so crucial here is that while this powerful feature works automatically, wffweb gives you, the developer, complete and granular control over how it behaves. And here is exactly how you do it. It's actually super straightforward. The framework gives you this use settings method. All you have to do is override this method in your own browser page class, and boom, you can swap out the defaults for your own custom logic. It's direct, it's clean, and it's powerful. And this is just a brilliant illustration of that flexibility. The default is a simple page reload, right? But what if, say, in your dev environment, you want to log that this event happened so you can debug it? Easy. You can provide your own little JavaScript snippet to write a message to the console before you trigger the reload. It's perfect for tracking down those tricky intermittent network bugs. And that control goes even further. It's not just limited to client-side JavaScript. You can define a custom Java action that runs on the server side. You can query what the current settings are. Or if your application has a use case where you don't need this level of protection, you can even turn the feature off entirely. You have total authority. So, let's wrap this all up. What's the bottom line? wffweb's lossless communication gives you automatic bidirectional protection right out of the gate. It actively prevents data corruption by making sure messages are always processed in the correct order. And on top of all that, it's fully configurable, giving you the power to make it behave exactly how your application needs it to. It's like having an unseen guardian for your UI state. And that really brings us to the end. After seeing how wffweb just so rigorously protects your app from the chaos of an unreliable network, it kind of leaves you with one last question to chew on. How confident are you, really, in your own application's state integrity when that connection inevitably starts to flicker? Something to think about. Thanks for joining me.